Hi everyone, welcome to this video. So this is the part one of this video series of where we go dive into fast and slow pointers algorithm. So in this video, mainly we're gonna be seeing how this fast and slow pointers algorithm works and different sort of examples where we typically use this pattern. And also we'll be checking some real world applications of this algorithm, and also at the end we'll see a way to find whether a problem requires this pattern or not. Yeah, so these are some of the things which we're gonna see in this video. So first we'll dive into what is a fast and slow pointers algorithm. We'll just see an overview on it. So basically this algorithm is also called something like Floyd's tortoise and hare algorithm. So basically, this technique or this algorithm is mainly used to detect cycles in a sequence. Cycles, I mean, such as linked list, array, or a string. String is nothing but a sequence of characters, right? So mainly, this technique is used to detect cycles or identify patterns in a given sequence, and also it will be used to find specific elements in the given data structure. Yeah, so these are the some of places where we generally use this pattern. So this similar to two pointers algorithm over here in fast and slow pointers as well. We'll use two pointers. Both will start from the same position, which is the starting beginning of the sequence, given sequence. But however, these two pointers move at different speeds through the sequence. So, but the speed at which we want to move the pointers depends on the problem statement. But the key difference between this fast and slow pointers and two pointers algorithm is the two pointer approach is mainly used where we are mainly concerned with what an element in the sequence contains. Suppose some of the example where we use two pointers algorithm is to find a pair in the given sequence whose sum is equals to some 80, 90 or some random number. Over here we are concerned about the value in the elements and check whether there exists any two elements in the sequence whose sum is equals to the any random number. So over here we are basically concerned about data values. So whereas the fast and slow pointers approach is mainly used to detect any pattern or any structure in the given data structure. So this is one of the difference between slow fast and slow pointers approach and two pointers approach. And also we have discussed in some of the problems where we use this fast and slow pointers approach till now. Yeah, so now we'll see go through this algorithm in detail. So these are the three steps which we're gonna be following in this algorithm. So first is we'll be initializing both pointers at the beginning of the sequence, and then we'll move both pointers at different speeds. So generally, in many problems, we'll move the slow pointer, which is also known as tortoise pointer, by a factor of one, and we'll move the fast pointer forwards by a factor of two. So, and the third step which we have to do is the detection. So basically, as we have discussed, mainly this technique is used to detect pattern in a given string data, right? So basically, it can be used to find whether there exists any cycle in a given data structure or whether there is a intersections between two arrays or two linked lists, something like that. For suppose if we want to find whether there exists a cycle in a linked list or not, so we will initialize both fast and slow pointers from the first element, and we'll move both pointers at different speeds. So if there is any cycle, it means that the fast pointer will eventually meet the slow pointer. So if there is no cycle in the given data, the fast pointer will basically reach the end of sequence. So to understand this in a better way, if you think of two runners on a track, on a running track, so both will be running both will be starting from the same point, but they will be running in different speeds. So if the track is circular, the runner who is fast will be eventually overtaking slower ones after completing a lap, right? So this is the same. This is the idea which we are using to find a cycle in a given sequence, such as linked list on or a string. Yeah, so this is all about the algorithm, how algorithm works. So these are some of the problems or where we'll be using this pattern. So one is to find middle node of a linked list. So we'll be given the head node of a single linked list, and we have to find the middle node of the linked list, and we have to return it. So here, fast and slow pointer will start from the same first node, and fast pointer moves by a factor of 2 and slow pointer moves by a factor of 1. When fast pointer reaches the last node, slow pointer will be at the middle of the middle node of the linked list. So this is one of the problem where we use this. So and the other problem is, as we have discussed, to detect a cycle in an array. So what I mean a cycle is, suppose if we have an array of non-negative integers, basically it is a positive integers, including 0. So where each element contains the value of the index to which it points to. Suppose if an element has a value called 2, that element basically is pointing to the index 2 of the given sequence. So since each element is pointing to some one of the element in the sequence, so there might be a cycle possible, right? So basically, we'll be using this fast pointers and slow pointers approach to detect if there is a cycle. If there is a cycle, fast pointer will eventually meet the slow pointer, and if there is no cycle, fast pointer will just go to the last element of the sequence. So these are two problems where we typically use this fast pointers and slow pointers approach. So now we'll find a way to identify whether a given problem requires this fast and slow pointers algorithm or not. So to verify that, we have to check whether these following conditions are met or not. So one is we need to have a linear data structure. So for to use this fast and slow pointers algorithm, we should have a linear data structure such as an array. Array is nothing but a list of elements, and linked list, which is nothing but a sequence of nodes, or a string. String is nothing but a sequence of characters. So we need to have a linear data structure so that we can traverse through the elements one by one. So this is one of the condition which has to be met. And in addition to this condition, either of these two conditions have to be met. So one is if your problem is like a cycle or intersection detection problem, it means that we have to detect a loop or a cycle within a given sequence, such as linked list or a string. Or else if you want to find an intersection between two sequences or between two linked list or array, then we can use this pattern. And another type of problem where we use this pattern is to find starting element of a quantile. So basically what a quantile is, suppose if we say it as q quantiles, it means that there exists q minus 1 values in the given sequence, which divides the given sequence is nothing but final sets values into q partitions. So each partition will should be of nearly same size. Then we'll say each the q portions as a quantile. We have q quantiles. So for suppose we can say in halves as a quantile. So the middle element of a linked list divides the linked list in two parts. So we have two quantiles, and two quantiles is partitioned by the middle element. And similarly, we have tertiles, quartiles. These all are quantiles, right? So basically, this algorithm can be used to find can also be used to find elements at specific positions within the given sequence. So particularly the values, it is mainly useful to find the elements that divides the data structures into quantals. Quantals, I mean half star, turtles, quantals, or in something which divides the some q minus one values which divides the given sequence into q parts. Yeah, so this is so one of these conditions has to be met, and this condition has to be met definitely. So if these conditions have been met, then we can use this fast and slow pointers algorithm. Yeah, so since we have seen how this algorithm works and some of the examples where we use this fast and slow pointers generally, and how to identify whether a problem falls under this fast and slow pointers pattern or not. Now we'll see some of the real world applications where we generally use this fast and slow pointers technique. So one is to verify the sim link. Basically, it is to verify there exist any loops. So basically, a sim link or a symbolic link is a file is nothing but a file which points to another file. Basically, which acts as like a shortcut. So since sim links point to each other, right? Sim link A points to B, sim link B two points to C. So there is a chance of loops or cycles since they are pointing to each other, so there is a chance that link A is pointing to B and B is pointing to A. So it can be either directly or it can be indirectly. So potentially, if you try to access such files, it will cause infinite loops. So to verify whether there exists any loops in the sim links, we can use this two pointers approach. So we'll be moving this slow pointer by one sim link at a time, and the fast pointer by two sim link at a time. So since both pointers will start at the same sim link, if there exists any loop, the fast pointer will eventually meet the slow pointer. If there doesn't exist, it won't. Fast pointer will won't meet the slow pointer. So basically, it will reach the last sim link, or which points to a non-existing file or the end of this sim link. So which says that there is no such cycle or loop. So this is one of the place where we use this fast and slow pointers technique. Another example where we use this fast and slow pointers technique is while compiling an object-oriented programming. So basically, an object-oriented programming will contain multiple modules. Each module will be dependent on a different module. So suppose if you have three modules, module A, B, and C. So there exists a scenario where we need to use object of module B in module A, an object of module B in module C, like that. So each module is interdependent on other module. So since each module is dependent on other module, there might be a chance of cyclic dependency. So for example, if we take Spring Boot, sometimes we might come across a scenario where compilation fails due to a cyclic dependency, right? So it means that we have reached a cyclic relationship where we need the bean of class A in B, and we need a bean of class A in class B and bean of class B in class A, which can be either caused directly or indirectly. So which will basically prevent the compilation of the program. So to ensure a smooth compilation, during the compilation, we'll be using this fast and slow pointers, whether there exists any cycles we discussed or not. If there exists any, it will be failing, and we have to make sure to remove that cyclic dependency, and then which so that we can run our code smoothly. So this is one of the other example where one of the other real world example where we use this fast and slow pointers algorithm. Yeah, so in this video we have basically discussed how fast and slow pointers algorithm works, how it is different to two pointers algorithm, and we have seen some of the examples, some of the problem type of problems where we basically use this pattern, and we found a way to identify whether the given problem requires a fast and slow pointers algorithm or not. And at the end, we have discussed some of the real world applications where we are using this fast and slow pointers technique. Yeah, so I will leave the sheet link of the sheet in the description of this video. Feel free to check this out. Yeah, so that's it for this video. In the next videos, we are going to be solving problems using this technique. So check that out. Yeah, so that's it for this video. See you in the next.